Hi everyone, in this video we are going to solve O-Levels Additional Mathematics Paper 1 in a session May-June 2022, Paper 1-1. So let's begin with the first question. Question number 1, find constants A, B, and C such that this is going to be this. Okay, so we need to simplify the left hand side first. So let me write down left hand side, and that is equals to P is 1 by 2, Q is 2 by 3, R is minus 3 over P Q inverse square. It means P power 2 and Q power minus 1 times 2 is minus 2 and R power minus 1. Okay, now I'm shifting all the powers into the numerator. So P power 1 by 2 into P power minus 2, Q powers 2 by 3 into Q power positive 2. Shifting this becomes positive. R power minus 3 and R power minus 1 turns to positive 1. So now the bases are same. We can add the powers. So P power 1 by 2 minus 2. Q power 2 by 3 plus 2. And R power minus 3 plus 1. Right. Now P. So let me simplify the powers. 1 by 2 minus 2. 1 by 2 minus 2 is minus 3 by 2. So P power is minus 3 divides 2. Q is 2 by 3 plus 2. 2 by 3 plus 2 is 8 by 3. And R is minus 3 plus 1 is minus 2. Right. So A value is minus 3 by 2. B is 8 by 3 and R is C is negative of 2. Question number 2. A particle moves in a straight line such that its displacement s meters from a fixed point at time t seconds t is greater than equals to 0 is given by this. So we have given the displacement. Now for A part, find the exact speed of the particle when time is 1. Okay, so we have given the displacement. We need to find the speed, and we know that speed is a scalar quantity and it does not have any direction, so it means speed never be negative. We need to take the positive speed. So speed is basically equals to the derivative of displacement with respect to time. So let me do it. ds over dt, we need to find ds over dt at t equals to 1, right? So let's simplify. So it is a power rule of derivative. So first we have a power, that's minus 1 by 2, the base 1 plus 3t and power minus 1, and the derivative d by dt of the base function, that is 1 plus 3t. Right, and we have minus 1 by 2, 1 plus 3t, and 1 by minus 1 by 2, and minus 1 is minus 3 by 2. This is minus 3 divides 2 and its derivative is 3. Right, so we have minus 3 by 2, 1 plus 3t, power is negative 3 by 2. Right, now we need to find the speed when time is 1. So we can say at t equals to 1, what is the answer? ds over dt at t equals to 1 is minus 3 by 2, 1 plus 3 times 1 is 3. So my power 3 minus 3 by 2. So 3 plus 1 is 4. So minus 3 by 2. 4 power is minus 3 by 2. Right. So let me simplify. So 4 power answer, and then times negative 3 and dividing by 2, that is negative 3 over 16. Minus 3 over 16 is ds over dt at t equals to 1. And we know that speed is a scalar quantity. Speed never be negative. So for the speed, we need to take the absolute value or the positive value only, that is 3 by 16 when time is equals to 1. Now for the B part, show that the acceleration of the particle will never be 0. Okay, so acceleration never be 0. It means we have the speed now. To get the acceleration, we need to take the second derivative. So we have, this is the speed function, right? So we need to find d2s over dt square. So minus 3 by 2 is outside. Now this is a function we have, taking its derivative times the power rule again, power, the base function, power minus 1, and the derivative d over dt of the base function, that is 1 plus 3t. Right. So we have 3 times 3 is 9, 2 times 2 is 4, and 1 plus 3t. Minus 3 by 2, subtract 1, minus 5 by 2. Power is minus 5 by 2 and its derivative is just 3. And 9 times 3 is 27. So we have 27 by 4, 1 plus 3t, and the power is minus 5 by 2. Right. So this is the acceleration, and we need to show that the acceleration of the particle will never be 0. So it means when time, whatever the time value, whether it is 0, positive or negative, this acceleration is always positive. So if I check at 0, so 1 plus 3 would be 4, and 4 power negative 5 by 2 is also positive. Checking on negative values or positive values, it is always positive. So we can say that 1 plus 3t power minus 5 by 2 is always positive. So when a positive quantity is multiplying with 27 by 4, this implies acceleration never be 0. We will get some number not equals to 0, right? Question number 3, a function f is such that we have a function f of x that is the natural log of 2x plus 1, where x is greater than minus 1 by 2. For a part, write down the range of f. Okay, so as you can see, we have given the domain that all the x values that are greater than minus 1 by 2, and when we put all the x values that are more than minus 1 by 2, we will get the outputs, and outputs are the range. So the resulting values are all belongs to real numbers. So we can say the range of f of x is f of x belongs to real numbers, because these are the outputs. When we substitute all the x values that are greater than minus 1 by 2, we will get the all real numbers. Okay, now a function g is such that we have given g of x, that is a linear function, 5x minus 7 for x belongs to real numbers. Now part B, find the exact solution of the equation g f of x that is equals to 13. So first we need to find g f of x. G of f of x is g, and f of x is ln 2x plus 1, and g of x is 5 times x, 5 ln 2x plus 1, and minus 7. Right, now put it equals to 17, right? So we have 5 ln 2x plus 1 minus 7 equals to 13. 5 ln 2x plus 1 equals to 13 plus 7. So 13 plus 7 is 20. Yes. So ln 2x plus 1 equals to 20, and then dividing by 5, 5 times 4 equals to 20, right? And we need to solve for the x value. So it means we need to take a natural log on both sides. Anti-log, sorry, ln of 2x plus 1 equals to e power 4. Natural anti-log and the log is cancel out. We have 2x plus 1 equals to e power 4. And from here, we have 2x equals to e power 4, subtract 1. And x is equals to 1 by 2 e power 4 minus 1. So that is the value for x, right? Now for part C, find the solution of the equation f prime of x equals to g inverse of x. First we need to find f prime of x, the derivative of f of x. F prime of x is equals to df over dx. It means we need to find d by dx of the function, that is ln 2x plus 1, right? And the derivative of natural log is 1 by x, the derivative of the function. So it is 1 over 2x plus 1, and the derivative of 2x plus 1, d by dx of 2x plus 1, and that is equals to just 2 over 2x plus 1. Right, now finding g inverse. To get the value for g inverse, first we have the function g, that is 5x minus 7. So we need to put y equals to g of x, y equals to 5x minus 7. That is the first step, right? Now for this next step, we need to just switch the variables. The variables x is replacing with y and y with x. So this y with x and 5y minus 7, and then solving for y. So x plus 7 divides 5 equals to y, and this y is g inverse of x. Right. Okay. Now let me simplify. We need to solve this equation. Now put f prime of x equals to g inverse of x. F prime of x is this, that is 2 over 2x plus 1, and put it equals to g inverse of x, that is x plus 7 over 5. Right. Now we need to do a cross multiplication. So let me do it here. Okay, 2 times 5 equals, we have 2x plus 1 times this, 2x plus 1 times x plus 7. Right, so let me simplify it further. So 2 times 5 is 10 equals to 2x square. 2 times 7 is 14x plus x plus 7. Right, now we have 10 equals to 2x square plus 15x plus 7, right? Okay, so for further simplification, we have 2x square plus 15x and 7, and subtracting 10. 7 minus 10 is negative 3. Yes, minus 3 equals to 0. Now we have a quadratic equation. So let me use a quadratic formula to get the value for x. So here the quadratic formula is x equals to negative of b value is 15, plus minus square root b square, 15 square, minus 4 times a value is 2 times c value is minus 3, and then whole dividing by 2 times of a value, that is 2. Right, so here x equals to minus 15 plus minus square root 15 square. 15 square is 225, and minus 4 times 2 times minus 3 is plus 24, and 2 times 2 is 4, and 225 plus 24 is 249. Okay, so here we have x equals to minus 15 plus minus square root of 249, and then dividing by 4. Okay, so we have the two values for x with a positive square root and with a negative square root. So let me find both one by one. So minus 15 plus square root 249 divides 4, that is 0.195, and we round to 3 decimal place. Okay, so the first x value is 0.195, and for the second we have minus 15 minus square root 249 divides 4, that is 7.69. yes, negative 7.69. Okay, now which one we have to say that it is a solution? So in the beginning we have given that x is greater than minus 1 by 2. So the values that are more than minus 1 by 2. So this is going to be the solution because x is greater than minus 1 by 2, or x is greater than minus 0.5. So this value is going to be the solution, x equals to 0.195. Question number 4, in A part, the diagram shows the graph of y equals to absolute of f of x, where f of x is a cubic function. Find the possible expressions for f of x. Okay, so function is a cubic function. For cubic function, we have the standard form f of x equals to a, x minus p, x minus q, and x minus r. Now what is p, q, r? P, q, r are the zeros, or x, y, x intercept, sorry. So x and 0 is minus 2, 1 and 3. So let me substitute the values for p, q, r. So we have f of x is a, x minus 2, minus 2 is plus 2, x minus q value is 1, x minus r value is 3. Now, how can you find the value for a, right? To get the value for a, we need to use the y-intercept, that is minus 24. So here the coordinate x is 0 and the y is positive 24. So let me substitute the point 0, 24 to get the value for a. So this is f of x, right? So we have 0, 24. F of x is 24 and x is 0. A, here we have 2, minus 1 and minus 3, right? So negative times negative is positive, 1 times 3 is 3 and 2 times 3 is 6. So 24 over 6, and 6 times 4 is 24. That is the a value, right? So we got the a value, that is 4. And keep in mind, y is absolute of f of x. So absolute function is always, when we open the absolute, we have positive and negative, right? So it means y is equals to plus minus f of x when we open the absolute function, right? So the final f of x function is going to be, substituting the a value, f of x is equals to plus minus, the a value is 4, x plus 2, x minus 1 and x minus 3. So this is the function f of x, the cubic function. Now for the b part, in 1, on the axis below, sketch the graph of y equals to absolute of 2x plus 1 and the graph of y equals to absolute of 4 into x minus 1, stating the coordinates of the points where the graph meets the coordinate axis. Okay, so on the same grid, we need to sketch the graph of the two absolute value function. So first we need to find the x and the y intercept. So if I start with this function, we have, let me do it here. We have a function y equals to 2x plus 1. I'm taking the function without absolute, right? So what is the x intercept or the y intercept? Let's solve. When x equals to 0, the y value is 1, right? So y equals to 1. We need to say, we can say just y is 1 here, right? And when y is equals to 0, the x is going to be, when y is 0, the x is minus 1 by 2. Minus 0.5 is this point, right? So let me connect the 2 points. This is minus 1 by 2 and this is 1. Right? Okay, so since it is an absolute value function, so it extends on the other side as well. So if we have from 0 to 0.5, the next x value is at 1. The same direction. It extends like, so the y value is the same 1 and this point is going to be minus 1, right? Okay, now let me do for the second one. The second is we have y equals to 4x minus 4, right? So the x-intercept and the y-intercept. Again, when x equals to 0, y value is negative 4. Okay, y equals to negative 4 is over here. Let's say this is minus 4. And when y equals to 0, what is the x? X is, when we put y equals to 0, x equals to 1, right? So x equals to 1 is this point, right? So let me connect these 2 points as well. and again it extends in the same way, like when the y is 1 here, and for 4 the other way is same. Sorry, x is 1 here, right? Again x is 1 here, opening the same because it is the absolute value function. And now we need to state that the graph meets the coordinate axis at this point and at this point. We just need to show that the point of intersection on the graphs. So these are the 2 points of intersections for the 2 absolute value functions of the graph. Question okay, now for part 2, find the exact solutions of the equation this. Okay, so whenever we find simplify the absolute value equation or function, so when we open the absolute, here we have plus minus 2x plus 1 and plus minus 4 into x minus 1 when we open the absolute, right? Okay, now to get rid of this plus minus, I want to scale on both sides. Scaling on both sides. Okay, so let me take the scale on both sides. We have just x plus 1, 2x plus 1 whole square equals to 4 square is 16 into x minus 1 whole square, right? So we have 2x square is 4x square, plus 2 times 2 is 4x plus 1, and here we have 16 into x square minus 2x and then plus 1, right? So first let me open this bracket. So we have 4x square plus 4x plus 1 equals to 16x square, and 2 times of 16 is 32. So negative of 32x and plus 16, right? Now shifting all the terms to the left side, we have 4x square minus 16x square plus 4x and plus 32x plus 1 and minus 16 equals to 0. Okay, 16. 4 minus 16 is negative of 12 x square, and 32 plus 4 is 36 plus 36x, and negative of 15 equals to 0. Okay, so now let me take a negative sign common. So we have 12x square minus 36x and plus 15 equals to 0. Okay, so we have a quadratic equation. Let me solve by using a quadratic formula. So x equals to negative of the b value is minus 36 plus minus square root b square minus 36 square minus 4 times the a value times the c value divides 2 times of a value, right? Okay, let's simplify it further. So x is equals to negative times negative is positive 36 plus minus square root 36 square 1296 1296, and we have 4 times 12 times 15 is minus 720. And 12 times 2 is 24. Okay, now further simplification, x is equals to 36 plus minus square root 1296 subtract 720 576 576, and then dividing by 24. So what is square root of 576? 24. So x is equals to 36 plus minus 24 divides 24. Now from here we have two values for x. X equals to 36 plus 24 divides 24, right? Or x equals to 36 minus 24 divides 24, right? So let me simplify one by one. So for the first value, we have 36 plus 24 divides 24 is 5 by 2 or 2.5. So this is 2.5. right? And the next is 36 minus 24 divides 24 is 1 by 2 or 0.5. So these are the two values for x. Question number 5 in A part, find the vector which is in the opposite direction of this vector and has a magnitude of 8.5. Okay, so we have given the vector, and if the vector is opposite of this direction, it means with a negative sign of this vector, right? Opposite direction means with a negative sign and has a magnitude 8.5. So first let me find the magnitude of this vector. Let's say this is a vector v. Right, so what is the magnitude of the vector v? Magnitude of the vector v is square root of 15 square plus negative 8 square. Okay, so we have 15 square is 225, square root of 225 plus negative 8 square. 8 square is 64. 8 times 8 is 64. And 225 plus 64 is 289. And square root of 289 is 17. So the magnitude of this vector is 17. If I divide 17 by 2, I will get 8.5. Okay, so we have the hint that 17 divides 2 is 8.5. So if the given vector is dividing by 2, we will get the vector having magnitude 8.5, and for opposite direction we need to multiply with a negative sign, right? So the vector is going to be, let's say v1, okay, with a negative, and if it is dividing by 2, negative 1 by 2 of the given vector 15 and minus 8. Now this vector has a magnitude of 8.5 and it is opposite direction to this vector because it has a negative sign. Now for the b part, find the values of a and b such that, okay, so just simplify. So we have, first let me multiply 5 with the vector inside. So 15, 5 times 3 is 15a, 5b plus 2a plus 1 and 2. This is equals to 6b plus 6a, and 2 times 6 is 12. Okay. Let me make, no, first let me add. 15 plus 2 is 17. 17a plus 1 and 5b plus 2, and this is equals to 6b plus 6a and 12. Now we have two equations. So the first equation is 17a plus 1 equals to 6b plus 6a, right? So we have 17a minus 6a minus 6b plus 1 equals to 0. Now 17 minus 6 is 17, take away 6 is 11. So here we have 11a minus b plus 1 equals to 0. This is my first equation, right? Now for the second equation, we have 5b plus 2 equals to 12. So 5b plus 2 equals to 12. From here we can easily find the b value. So 5b is equals to 12, subtract 2, that is equals to 10, and 10 by 5 is 2. So the b value is 2. So we got the b value. Now let's substitute the b value here to get the a value, right? Now the a is going 11a minus 6 times 2 plus 1 equals to 0. 6 times 2 is 12. So 11a minus 12 plus 1 equals to 0. 11a equals to 11. So a is going to be 1. So the a value is 1 and the b value is 2. Now question number 6 in a part, write down the values of k for which the line y equals to k is tangent to the curve, this curve. Okay. So we have given the sine function. So if I draw the sine graph, just to visualize. So sine graph starts from origin, just sine x. This is the sine curve, right? Okay, and the tangent is a point which touches the curve at exactly one point. So if it can be at the maximum point, is going to be the tangent, or the minimum point is going to be the tangent, right? So we got the hint that it can be the maximum or the minimum value, right? So we need to find the max and the minimum. So we have y equals to 4 sine x plus pi by 4 plus 10. So 4 is the amplitude, 10 is the equation of axis, pi by 4 is the phase shift. So for the maximum and the minimum, so the maximum point is amplitude plus equation of axis, we add. So the amplitude is 4, equation of axis is 10, so we have 14, the k value is 14. Or for the minimum, we can find the minimum is equation of axis minus amplitude, that is 10 minus 4, it can be 6. So we will get the 2k values for the line y equals to k, that is tangent to the given curve. So y equals to 14, or we can say y equals to 6. The 2k values are 14 and 6. Part B, show that this equals to this. So we need to prove the identity. Okay, so let me start from the left hand side. This is the left hand side, and prove the right hand side. So the left hand side, okay, so let me take the LCM first. So we have 1, okay, so 1 minus cos x and 1 plus cos x is going to be the LCM, and it is going to be the opposite, multiplying with the opposite denominator, basically a cross multiplication. 1 plus tan theta, sorry, is multiplying with 1 plus cos theta, the cross multiplication, plus 1 minus tan theta is multiplying with 1 minus cos theta. Okay, and divide it by 1 minus cos theta into 1 plus cos theta, right? So let me simplify now. Do the multiplication, open the brackets. So 1 plus tan theta with 1 plus cos theta. 1 times 1 is 1 plus cos theta plus tan theta plus cos theta into tan theta, plus 1 times 1 minus cos theta minus tan theta, minus times minus is plus cos theta tan theta, right? Okay, now divide it by 1 minus cos square theta, because 1 minus cos theta, 1 plus cos theta is 1 minus cos square theta. A plus b into a minus b is a square minus b square. Okay, now let me cancel the terms. Plus cos theta minus cos theta plus tan theta minus tan theta. Okay, so now we are left with the 1 plus 1 is 2 cos theta tan theta, and cos theta tan theta is 2 cos theta tan theta. So we have 2 plus 2 cos theta tan theta over 1 minus cos square theta. Okay, so now here we are using cos theta, and tan theta is sine by cos theta. Sine theta by cos theta, so this is just sine theta, right? And we are using an identity that cos square theta plus sine square theta is equals to 1, and sine square theta is going to be 1 minus cos square theta. So this 1 minus cos square theta is just sine square theta. So let me write it down. 2 is common, 1 plus this cos theta tan theta is just sine theta, and this is going to divide with sine square theta. So this is equals to over right hand side. This is proved, right? Now for the second part, hence solve the equation. This term equals to 3. So as you can see, it exactly equals to this. So basically this answer is going to be equals to 3, and the theta value is between 0 to 360 degree. So now let me put this equals to 3, and we have 2 1 plus sine theta over sine square theta equals to 3, and we need to solve the values for theta, and theta lies between 0 to 360 degree. So let's do a cross multiplication. So we have 2 into 1 plus sine theta is 3 sine square theta, right? And we have 2 plus 2 sine theta is 3 sine square theta, right? And it's a quadratic equation. Let me simplify, moving all the terms to the right side, or we can say that 3 sine square theta minus 2 sine theta minus 2 equals to 0, right? So let me solve it by using a quadratic formula. So here we have a variable sine theta. We need to solve it as sine theta. So sine theta is equals to negative of b, so negative 2 plus minus square root b square minus 2 square minus 4 times the a value times the c value divides 2 times of the a value, right? So we have 2 plus minus square root 4, negative times negative is positive, 2 times 3 times 4 is 24, plus 24, and then dividing by 2 times 3 is 6. 24 plus 4 is 28. So 2 plus minus, this is sine theta and sine theta, square root of 28 and divides 6. Okay, so here we will get the two values for sine theta. So let's do it with a positive one and the negative one, right? So we have 2 plus square root of 28 divides 6, that is sine theta equals to this value. And when we solve the theta, we do the theta inverse. Sine inverse of this is undefined, so we can't take the first value, right? So for the second, 2 minus square root of 28 divide 6, this value, and doing a sine inverse, so we can take this value, yes. Okay, so 2 minus square root of 28 divide 6, negative 0.485. So we can take sine theta equals to minus 0.5485, right? So sine is negative in which quadrants? We need to find the quadrants first. So let me draw the quadrants. Okay, so this is a coordinate system. So for the first quadrant, all trigonometric ratios are positive. Sine is positive, tan is positive, and cos is positive. Here we have theta, here we have 180 plus theta, here we have 180 minus theta, and 360 minus theta, 180, sorry, right? So we have an equation, sine theta is negative of 0.5485. So sine is negative in the third and the fourth quadrant. So it means theta is going to be sine inverse of minus 0.5485. Okay, so let me convert my calculator into degrees, because we are dealing with the degrees. So sine inverse 0.5485. So this is 33 degrees, 33.20, 6. Yes, so theta is going to be 33.26 degrees, right? So we will get the two values for theta, for positive and the negative one, for third and the fourth quadrant. So for the third quadrant, we have 180 plus theta, right? So in this value, just add 180 degree. So we have 213.25 or 213.3 degrees, right? And for the next is a fourth quadrant. That is 360 subtract theta, right? So 360 minus theta is 33.25. That is 326.74 or 326.7 degrees. So these are the two values for theta. Question number 7 in A part, the first three terms of an arithmetic progression are ln 3, 3 ln 3, 5 ln 3. Given that the sum to n terms of this progression can be written as 256 ln 81, find the value of n. Sum to n terms. So means Sn we have given is this. Okay, so first we need to find the formula for Sn, the sum of arithmetic progression. The formula for the sum of arithmetic progression is Sn is n by 2 into 2a plus n minus 1 into d. Okay, so a is the first term, that is ln 3, and d is the common difference, right? So let me find the d value. So d is basically the second term, subtract the first term. The second term is 3 log 3 minus log 3. So 3 minus 1 is 2 log 3. 2 log 3 is the common difference. So let me substitute the values and simplify. So the sum is given. So we have, if I can say n by 2 into 2 times a value is log 3 plus n minus 1 into d is 2 log 3 equals to 256 log 81. Right. Now we need to solve the value for n. So let me open this bracket first. So n by 2, 2 log 3 plus 2n log 3 minus 2 log 3 equals to 256 log 81. Okay, so we have 2 log 3 minus 2 log 3 is just cancel, and we have and this 2 is also cancel. We can cancel 2 and 2. N times n is n square and log 3. So n square log 3 is 256 log 81. Okay, so we need to make the same log 3 and log 81. So 81 is, if we take 3 power 4, 3 power 4 is 81. So here 3 power 4 is 81. So we can replace this 81 with 3 power 4. And here we have n square is log 3 equals to 256 log 3 power 4. And by using the power property of log, that power comes first before the log. So we have n square is log 3 equals to 256 times 4 log 3. Right. Now cancel the log 3. And we have n square is 256 times 4 is 256 times 4, 1024. 1024, and we have n square, so square root of 1024 is 32. So the n value is 32 by taking the square root. Okay, part B, do not use a calculator in this part of the question. The first three terms of the geometric progression Now we have a geometric progression r ln natural log of 256, natural log 16, and natural log 4. Find the sum to infinity. S infinity, basically, we need to find of this progression. Give your answer in the form of p ln 2. Okay, so that's easy. So first we need to write down the formula for S infinity. So we know that S infinity is a over 1 minus r. So a is the first term. We know the first term is ln 256, right? R is the common ratio. So let me find the common ratio. Common ratio, that is r, that is equals to the second term divides first term, right? Okay, so r is equals to second term is ln 16 over the first term is ln 256. So let me simplify. This is a natural log. Natural log of 16 divides natural log 256, that is 1 by 2. R value is 1 by 2. Okay. Right, so just substituting the values into this infinity formula. So we have S infinity is going to be, a value is ln 256 divides 1 minus 1 by 2 because R is 1 by 2, right? And we need to find the formula is ln 2. So 256, we need to convert it into the power of 2. Okay, so if we take 2 power 8 is 256. Yes, we got it. So 2 power 8 is 256. So S infinity is going to be natural log of 2 power 8 over 1 minus 1 by 2. 1 minus 1 divides 2 is 1 by 2. Or when we do the reciprocal, it is just 2. It comes into numerator. Yes. S infinity is 2 times, and this power comes first, 8 ln of 2. Right. And 2 times of... now S infinity is 2 times 8 is 16, natural log of 2. So we got the answer in terms of p, natural log of 2. So the p value is 16. Question number 8. Do not use a calculator in this question. For A part, find the exact coordinates of the points of intersection of the curve and the line. Okay, so we need to find the point of intersection of a given curve and the line. So it means we need to substitute both of them equal. So why is this? So put it here. So x square plus 2 square root 5x minus 20 equals to 3 square root of 5x plus 10. I just put both the curve and the equation equal, right? And now let's simplify, shifting all the terms to the left side. So we have x square plus 2 square root of 5x minus 3 square root of 5x minus 20 minus 10 equals to 0. So x square and 2 minus 3 is minus 1. Minus square root 5x and minus 30 equals to 0. Right. Okay, and now it's a quadratic equation. Let me solve it by using the quadratic formula. So x is going to be negative of b plus minus square root b square minus square root of 5 whole square minus 4 times a value times the c value divides 2 times of a. Right. For further simplification, x is going to be square root of 5 plus minus square root. This is just 5, and negative times negative is positive, and we have 4 times 30 is 120 plus 120 and then divides 2. Okay, 120 plus 5 is 125, and square root of 125 is 5 square root of 5. Okay. So x is equals to square root of 5 plus minus 5 square root of 5 divides 2. Right. Okay, let me take the square root of 5 common. So x is going to be square root of 5 is common from the numerator, and we have 1 plus minus 5 divides 2. Okay, now we have the two values for x. So if I solve it here, x is square root of 5 divides 2, 1 plus 5, or x is square root of 5 divides 2, 1 minus 5. Okay. So 1 plus 5 is 6 and 6 divides 2 is 3. So this is 3 square root of 5. And from here 1 minus 5 is 4. Negative 4 divides 2 is negative 2 square root of 5. Now we have two x values. We can substitute both one by one into the line, the equation of line we have given to get the y values, right? So the equation of line we have given is y equals to 3 square root of 5x plus 10, right? So when x is equals to 3 square root of 5, let me substitute the first value. Y is going to be 3 square root of 5 times 3 square root of 5 plus 10. So y is equals to 3 times 3 is 9. Square root of 5 times square root of 5 is 5 plus 10. Okay, so now we have 9 times 5 plus 10. 9 times 5 plus 10 is 55. Y is 55, right? And for the second, when x is minus 2 square root of 5, this value, y is 3 square root of 5 minus 2 square root of 5 plus 10. So y is going to be 2 times 3 is 6 minus 6 times 5 plus 10, right? Minus 6 times 5 plus 10 is negative of 20. So y is minus 20. Okay, so the exact coordinates of points of intersection are x is 3 square root of 5, the y is 55, and when x is minus 2 square root of 5, the y is negative of 20. So these are the two exact coordinates of point of intersection of the curve and the line. Now for B part, it is given that tan theta is equals to this. For theta is between 0 to pi by 2. Find cosecant square theta in the form of a plus b square root of 3, where a and b are constants. Okay, so tangent is given and we need to find cosecant square theta. So here we use the identity that cosecant square theta is 1 plus cot square theta. This is the identity. So we have given the tangent. We can easily find the value for cot by doing the reciprocal. So tangent reciprocal is cot. Tangent is basically 1 by cot. So it means cot theta is the reciprocal of this term. So 2 plus square root of 3 over square root of 3 minus 1. Right. So let me substitute the value over here to get the answer. Cosecant square theta is going to be 1 plus cot square theta, that is 2 plus square root of 3 over square root of 3 minus 1 whole square, right? So let me do the LCM and open the squares. So we have square root of 3 minus 1 whole square plus 2 plus square root of 3 whole square over square root of 3 minus 1 whole square. That is cosecant square theta, right? So for further simplification, we have 3 minus 2 square root of 3 plus 1 plus 2 square is 4 plus 4 square root of 3 plus 3 divides we have again 3 minus 2 square root of 3 and then plus 1, right? So let me simplify it. So that is going to be 4 square root of 3 and minus 2 square root of 3 is just 2 square root of 3. 3 plus 4, 3 plus 1 is 4, 4 plus 4 is 8, and 9, 10, 11, plus 11 divides 4 minus 2 square root of 3. Now let me rationalize this. So 4 plus 2 square root of 3 multiplying and dividing with 4 plus 2 square root of 3. Okay. So this is going to be 2 square root of 3 plus 11 is multiplying with 2 square root of 3 plus 4 over 4 square minus 2 square root of 3 square, because we have a minus b into a plus b is a square minus b square, right? So let me multiply this term with this term. 2 times 2 is 4, and square root of 3 times square root of 3 is just 3. And 2 times 4 is 8 square root of 3. 11 times 2 is 22 square root of 3. And 11 times 4 is 44. 4 square is 16 minus 2 square is 4 times 3. 4 times 3 is 12. So this is 22 plus 8 is 30. 30 square root of 3, and 12 plus 44. 12 plus 44 is 56. Divides 16 minus 4 times 3 is 12. So 16 minus 12 is just 4. So dividing by 4, 30 by 4 and 56 by 4. 30 divides 4 is 15 by 2. Or we can just say 56 by 4 plus 30 square root of 3 divides 4. So we have 56 by 4 first. 56 divides 4 is 14. Plus 30 divides 4 is 15 by 2. 15 by 2 square root of 30. So this is in the square root of 3. So this is in the form of a plus b square root of 3. Question number 9. A circle, center O and radius r centimeter has a sector OAB of fixed area 10 centimeter square. So area of a sector is 10 centimeter square. So we know that area of sector of a circle, when the radius in terms of radian, its formula is half theta times radius square, right? And this is equals to 10, right? So it means half theta r square is 10, right? And 2 times 10 is 20. So theta is going to be 20 divides radius square, right? So we have radius r, theta is 20 by r square. Angle AOB is theta radians, and the parameter of a sector is p centimeter. For a part, find an expression of p in terms of r. So parameter of a sector AOB is means OA plus OB plus AB. This is the parameter. So OA is a radius, that is r. OB is a radius, that is r. AB is arc length, and the AB is arc length. Yes, the formula for arc length in terms of radian is just r theta. So we have 2r plus r times theta is 20 by r square. So this r is cancelled with this r. So the parameter is 2 times of radius plus 20 by radius. Now for B part, find the value of r for which p has a stationary point. So p has a stationary point when the first derivative of p equals to 0. So dp over dr, so its derivative is just 2, and this is minus 20 over r square. Now put it equals to 0 to get the value for r. So we have 20 over r square is equals to 2. Now for cross multiplication, we have 20 equals to 2r square, and 20 by 2 is equals to 10, that is equals to r square. And the values for r when for which p has a stationary point, r is equals to square root of 10. This is a value of r when p has a stationary point. Now for part C, determine the nature of this stationary point. To get the nature of the stationary point, we have to take the second derivative of p. So d2p by dr square means d by dr of this term, that is 2 minus 20 over r square. So 2 is constant minus 20 by r square. So constant derivative is just 0. So we have negative of 20, and 1 by r square, its derivative is negative of 2 over r cube. 2 times 2 is 4, so that is 40. So 40 over r cube, and this is positive. So when second derivative is positive, it means the stationary point is minimum. Okay. Now for part D, find the value of theta at this stationary value. Okay. So finding the value for theta at the given stationary value. Stationary value r is square root of 10, and the theta we got is 20 over r square. This is the value for theta, 20 by r square. So let me find the value of theta at this stationary point. So r squared, sorry, not cube. Okay, so that is 20 over r squared is 10. So 20 by 10 is 2. So it means the value of theta at the given stationary point is 2. Question number 10. The normal to the curve at a point P with the coordinates P minus 1, where P is between 0 and pi by 6, meets the x-axis at point A and the y-axis at the point B. Find the exact coordinates of the midpoint of AB. Right. So first, we have given the information that normal to this curve at a point P with a coordinate this. So first we need to find the coordinates for point P. Let's do it step by step. So first, coordinates of point P, that is P minus 1. Okay. So to get the coordinates for the point P, we need to substitute this point into the given curve. So y is minus 1 and x is P. So we have minus 1 equals to 10 3p plus pi by 2. Right. So now the tangent is, this is, let's say, theta, right? So tangent theta is negative of 1. So we need to check on which quadrant tangent is negative. So let me draw the coordinate system. And P is in pi, right? So in the first quadrant, all trigonometric ratios are positive. In second, sine is positive. In third, tangent is positive. And in fourth, cosine is positive, or cos is positive, right? And in first, we have just theta. Here we have pi minus theta, pi plus theta, and 2 pi minus theta. Yes. Okay, so now the tangent is positive in first and third, and in negative in second and fourth quadrant. Right. So first let me find the value for theta. So we have, if I can do, 3p plus pi by 2 is tangent inverse of 1. We are solving for positive 1, and we know that the tangent is negative in these two quadrants. First, we need to solve the values for p. Yes. So tangent inverse of 1 Let me put the calculators in radian. 2. Okay. Tangent inverse of 1 is pi by 4. Okay, so 3p plus pi by 2 is equals to pi by 4. Right? So this implies that the theta value we got is pi by 4. Now tangent is negative in second and fourth. So let me solve for the second quadrant. We have pi minus theta. So we need to do 3p plus pi by 2 equals to pi minus pi by 4. So we have 1 minus 1 by 4 is just 3 pi by 4. So 3p plus pi by 2 is 3 pi by 4. And then 3p is equals to 3 pi by 4. And then minus pi by 2. Minus 1 by 2 is pi by 4. So here we have 3p is equals to pi by 4. And then 4, this is multiplying and now dividing. 4 times 3 is 12. So pi by 12. So the p value is pi by 12. And in the beginning of the question, we know that the p must lies between 0 to pi by 6. Pi by 6 is basically 30 degrees. So between 0 to 30 degrees. And what is pi by 12? If we do in terms of degrees, so 180 divides 12 is 15 degrees. So it means it belongs to the domain. Yes. Now let me check for the next quadrant. It says it is negative in the fourth quadrant as well. So for the fourth quadrant, we can say 3p plus pi by 2 is going to be 2 pi minus theta value. Theta is pi by 4, right? Yes, 2 pi minus the theta value. 2 pi minus pi by 4. So 3p plus pi by 2 is 2 minus pi by 4. That is 2 minus 1 by 4 is 7 pi by 4. And 3p is 7 pi by 4. Subtract pi by 2. 7 by 4 minus 1 by 2 is 5 pi by 4. So 3p is 5 pi divides 4. And 3 times 4 is 12. So the p value is 5 pi by 12. So let's see, 5 pi by 12 is in the domain. 5 times 180 divides 12 is 75. 75 does not belongs to the domain because domain is between 0 to 30 degrees. Okay, so now we have the p value, that is pi by 12. Now what is the coordinate for p? That is p minus 1. So that is pi by 12 minus 1. So coordinate of point P is pi by 12 and minus 1. So we have done with the first step, right? Okay, now for the second step, we need to find the equation of normal because we have given the information that normal to this curve at a point P, it meets x-axis and y-axis. So the next step is finding the equation of normal. Equation of normal is y minus y naught is equals to minus 1 by m into x minus x naught. Okay, now we have x naught and y naught. X naught, y naught is pi by 12 and negative 1, right? What is m? M is the slope. So let me solve for m. M is basically dy over dx, right, at the point P, right? dy by dx at point P, right? So the derivative for tangent is secant square of 3x plus pi by 2, and the derivative of 3x plus pi by 2 is just 3, right? Now putting the value, that is pi by 12. Okay, substituting the point P, the x value is pi by 12. So we have slope at the point P is secant square 3 pi by 12 plus pi by 2, and this is 3 basically here. Okay, so we have 3 divides 12 is pi by 4. 1 by 4 plus 1 by 2 is 3 pi by 4. So this is 3 secant square 3 pi by 4. So we know that secant is basically the reciprocal of cos. So if we can say this is 3 over cos square of 3 pi by 4. So we have 3 and cos is, okay, so 3 pi divides 4 and doing cos of that answer and then squaring, we have 1 by 2. In the denominator we have just 1 by 2, and we have 3 times 2, that is equals to 6. So now the m value is 6. Now just substitute the value. So y minus y naught is 1, negative 1 equals to minus 1 over m value x minus x naught is pi by 12. So that is the equation of normal, right? And it says that it meets the x-axis at point A and y-axis at point B. Okay, so when the curve meets the x-axis, the y value, y coordinate is equals to 0, right? At x-axis, y is equals to 0, right? So just substitute y equals to 0 and solving for the x. So when y equals to 0, so minus 1 by 6 x minus pi by 12 equals to 1, right? And let me solve for x. So x minus pi by 12 is equals to negative of 6, and x is equals to minus 6 and plus pi by 12. So the a, is basically, let me write down the point A, because at x-axis it meets at point A. So the point A, the x coordinate is pi by 12 minus 6 and 0. This is the coordinate for A. And for y-axis, when the curve meet at y-axis, we will get the point B. We have x equals to 0. So if I put x equals to 0 here and solving for y, we have y plus 1 equals to minus 1 by 6 and minus pi by 12, right? So negative times negative going to be positive, and 6 times 12 is 72. So y is pi by 72 subtract 1, right? And now the coordinates for point B we will get is the x is 0 and the y is pi by 72 subtract 1. Now we have the x, a and the b coordinate, just finding the midpoint for AB. So a is, let me write down again, a is pi by 12 and minus 6 comma 0, and b is 0 comma pi by 72 subtract 1. Okay, for the midpoint of AB, the formula is x1 plus x2 divides 2. So x1 plus 0 divides 2, so it means pi by 12 minus 6 divides 2, comma 0 plus this divides 2. Pi by 72 subtract 1 divides 2. So this is going to be pi minus 6 times 12 is 72 divides 2 times of 12, and pi minus 72 divides 2 times of 72. So pi minus 72 divides 24, and pi minus 72 divide, what is 2 times of 72? 2 times 72 is 144. Okay, let me simplify it further. So here we have pi by 24, subtract 72 by 24, pi by 144, subtract 72 by 144. So the exact coordinates for midpoint are pi by 24, and 72 divides 24 is 3. Subtract 3, and pi by 144, 72 divides 144 is 1 by 2, minus 1 by 2. So this is a midpoint of AB. So this is the last question of our paper. If you have any queries, please let me know in a comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.